Hey folks, let's take a look at lesson 11.4, part A, okay? And we're going to find something called the rates of change. And here's the nice thing. The number that you call step is really called rate of change. So when you're looking at a table like this and it says, hey, please find the rate of change, then you just have to go and find the step number like we always have. What's happening to go from 3 to 6? And then what's happening to go from 1 to 2? And what we taught you was that you need to put your y change on top of your x change. So it would be 3 over 1 or 3, right? And that's the same thing that this next line is saying right here. You can represent this relationship with a ratio, the change in number of feet. Well, feet is your y. So we'd say, hey, what's your change in y? That's what that triangle means. What's your change in y? Well, it changed by 3. And then what's the change in yards? Well, if you look at your table, yards is your x, so it's another way of saying what's your change in x? And by putting a triangle in front of the x, that's asking that, hey, what's your change of x? Well, it changed by 1, so we'll put a 1 right here. And then you simplify the fraction if possible. What's 3 divided by 1? It's 3. Now, sometimes your rate of change is a fraction. Sometimes it's an integer like this. That's fine, but that's what we want it to be, the change of y over the change of x. And that's how we can find it from these tables. It's very straightforward, right? And we've already done it. It's the same thing as finding your step number. It's the exact same thing. In fact, no one calls it a step number. We just told you that the last chapter to get you comfortable with the idea. Now we're going to call it by its proper name. Find the rate of change. So this whole lesson is finding the rates of change from tables. But we also want you to find the rate of change from a given graph. So let's go take a look at this graph. And if you're taking notes, yes, what we're going to do is we're simply going to take this table and put it into this graph down here. And so to save time, I'm just going to go ahead and have it shown up on the screen for you, okay? So here we go. We've got it fully graphed. And look, 1 yard would be equal to 3 feet, and we see that from our table, but it's better shown on the graph here, I think. 2 yards would be equal to 6 feet, 3 yards would be 9 feet, and 4 yards would be 12 feet. But how can we find our rate of change? Early on, I would recommend that you write triangle y over triangle x, change of y over change of x, so that way you can just have a template of where you should put in these numbers. Now I'm going to color code this just so that way it's a little easier to see. Pick 2 dots on here. Let's just choose this point and this point. I would have to go up how many units? You can see here it's 3 blocks, right? So my y change would be 3. And that's what's so important in making sure that you put your y change on top. If you put this one on the bottom, it'll make your rate of change upside down and it won't be the same number. Now, your change of x is your horizontal change, and we have to slide over here by 1. So my x change, my change in x, would be 1. And then if you can simplify your fraction, you go ahead, and in this case, sure, yeah, it's 3. Now, do you have to use these 2 dots right here? No, you can use any dots on here at all. In fact, why don't we put a dot right here at 0, 0, because if you have 0 yards, you have 0 feet, so that's a legitimate point. And you can see if I use these 2 dots, it would be the exact same thing again. Right? And that's the reason we used to call the rate of change the step number, because this number right here, if you actually did this, it makes the step so you can see it, and it continues and goes on and on and on. So how can we get a rate of change from a graph? Well, basically you start trying to find the step between 2 of your points. But let's do this one last thing right here. Let's say that we use this 3rd point right here and we skip this one, so we want to go from this point all the way to this point. Can we get the exact same rate of change? Well, if we simplify it, yes. So our vertical change was 6 and our horizontal change was 2. Well, folks, what's 6 divided by 2? It's 3. And if we chose something like to go from this point here all the way up to this point, it'd be a little ridiculous, but we could. You would have to go up 12, and then you would come over 4 units. Well, what's 12 over 4? It's still 3. So this is a constant rate of change. This number is found anywhere that you want on this graph. You choose 2 points. If you're looking for the easiest way, find the 2 points that are closest together so you don't have to count up and over as much. Okay? Let's go look at one other question. We have here this scenario. A student drops an egg from a window 200 feet above the ground, and the egg was able to safely land on the ground after 60 seconds. So let's graph this. At 0 seconds, that egg is 200 feet above the ground, so we need to put a dot right here to show this is where the egg started. Now, after 60 seconds, the egg is safely on the ground, so its height is at 0, but time has passed, and now 60 seconds later, the egg is not 200 feet up in the air, it's on the ground right here. How many points do we need to find the rate of change? We just need 2 points on here, right? That's it. That's all that we need. So let's go put change of y over change of x, just so that way it's a template. So there we have it. Our egg is going to fall 200 feet down over a certain amount of time. So our change is not 200. Because it's going down, it's actually minus 200 or negative 200. And that's a very important part, putting that negative there, because we're saying that we're going down. Our negative numbers make us go down, right? Now, what is our change of x? Well, to get from here all the way out here to the only other point that we have at this point, it's going to be a change of 60 seconds. And for this type of scenario, I think it's really important to just go ahead and label what's going on. Our x's are, in this case, seconds, and our y's are feet. So let's put feet right here. And let me color code the x's. Now, if I wanted to, I could absolutely just draw a straight line. In fact, let me just use this pencil right here to connect these 2 points. All it takes is 2 points to draw a line. There it is. There's the graph. But I'd like to do this. Can we simplify this just a little bit? Maybe not all the way down to lowest terms, but this would be negative 100 over 30. So it'd be drop 100 feet and move 30 seconds. So let's go show that. Dropping 100 feet would take us down to here, and then we'd have to move over 30 seconds. And so it stops right here, so we could put a dot right here. Let's put this pencil beside it and see if that dot lines up with our other 2. Yeah, that looks really good there. But could we just divide this by 2 again? Well, sure we can. And that would get us negative 50 over 15. So drop 50 feet within about 15 seconds. Let's just move down from this one. Let's have it drop 50 feet. So we're at 100 feet right here. And now we've dropped it 50 feet, so we're down to the 50-foot level. And then we're able to move it over 15 seconds, and that is our new location. At 45 seconds, our height is at 50 feet. We can put a dot right here. And then you can see again, it can drop by 50 feet and move over 15 seconds, and we're down on the ground. All of these dots are legitimate. And there's another point that we could put right here. How do I know it? Because I can drop 50 feet and move over 15 seconds. See how that's right at 15 seconds? And so all of these dots are making a fantastic line, and this rate of change is very, very useful. Now, if I divide both of these by 5, my most simplified version would be negative 10 feet over 3 seconds. And that's not very useful for this graph because I'm not going up in 3-second increments. But the 15-second, the 30-second, and the 60-second, all of those are very useful for this particular graph. So the rate of change is just your change of y over your change of x, and it helps you go get some different points on these scenarios. And the big thing is that your change of y is always going to be labeled with whatever your y value is, your y-axis is labeled as, and your x change will always be labeled with what your x-axis is. And the last thing I'd want to do is just go ahead and connect these points with a line. However, I'm not going to put an arrow down here because the only thing our parachute drop wants to show on this graph is what was the height of the egg before you dropped it, and then what was the height at every single second until it touched down to the ground. So I don't need to find out later on that the egg's just sitting here. I don't need to find out what's happening with the egg's height before we got it up to the top of the building. We just need to have from this point to that point, and that's the reason I'm not putting arrows on it. It's just not needed for this scenario.